The last thing we need to talk about is what do we do with these percent increases and decreases, which are always exponential no matter what every single time. Percents are always going to involve multiplication. So if we have a percent increase or decrease, it will be exponential, but there will be a little bit of a twist that we need to discuss here. So if we look at this problem, you put $300 in a bank account that makes 5% annual interest. So in this case, if you have a savings account, the bank gives you that 5% annual interest. So this is a price increase. It's a good thing in this case when you have a bank account. Now, since it's a 5% annual interest, you get that 5% every year. It kind of sounds linear, but percent increases or gains are always exponential. So we're going to write a y equals some number outside to the x. Now we put $300 in here. That's going to stay just as easy. But getting our multiplier when it comes to percent changes is a little bit different. So what we have to remember is when we have percent changes is we always start at 100%. And then we add or subtract the idea from the word problem based on what makes sense. So we're always going to start at 100%. Now, if we make 5% annual interest, that means we get the 5%, so we're gaining it. So we always start at 100%. We get the 5% interest every single year, and we end up with 105% at the end of every single year. Now, we need to take this percent and turn it into a decimal. So we will move the decimal over 2 places, or divide by 100, and we get 1.05. And that's the number that actually will go in for your equation. When you have a percent increase or decrease, we always start at 100. You add or subtract based on what makes sense. Take your answer, turn it into a decimal. That's what you actually need. So let's look at this one. The population in Broomfield, Colorado was 2,500 back in 2004. And it's grown at a steady 8% rate since. So how many people live there now? So if we look here, we're growing at 8%. Percent changes are always exponential. So we're going to have a y equals some number outside of a parentheses to the x. Now the population started at 2,500 people. We need to figure out the multiplier. So it's growing at 8%. So we always start at 100. So I'm going to write a little 100% over here. If it's growing, we're going to add that 8% to the population. We're going to end up with 108%. We just have to move that decimal over 2 places to get 1.08. And that's the number that you need inside of your parentheses. Let's try one more example. You drink a Monster energy drink with 120 milligrams of caffeine, and every hour the caffeine in your system will decrease by about 12%. So if we're decreasing by 12%, percent change is always exponential. So I'm going to write a y equals some number parentheses to the x. After you finish the Monster, we start with 120, and now we need to figure out the multiplier. So we're decreasing by 12%. We're decreasing by 12. So we always start at 100, but this time we're decreasing. So we're going to subtract that 12%, and we're going to end up with 88% of our caffeine every hour. We're going to take that decimal and move it over 2, and 0.88 is the number I actually need to show a 12% decrease. Now let's just look at this last one here. Mr. Graves buys a car for $9,000 and each year the value decreases by 11%. So which one of these equations was correct to show the value of his car? If you notice, they all look exponential because it's a percent increase or decrease. Now they all have the same starting value up front, the 9,000. So the question is which student correctly took a decrease of 11% and put it into the multiply. Now remember, if we want to check this, you always start at 100, and the car is decreasing by 11%, which leaves us with 89%. Now if we turn that into a decimal, we should see 0.89 as the multiplier, which we see in the blue equation here. This student just used the 11, totally wrong. This student accidentally added, and that's not how cars work. So the blue equation would be correct.